Okay, so we are going to continue our unit in our rational numbers, and we're going to start talking about additive inverses. When we talk about an additive inverse, we are going to be looking at the definition of an additive inverse, and we're going to show that an integer and its opposite will always have a sum of 0. So we have to first start out with talking about what is an integer. So an integer is a positive or a negative whole number. For example, we can have 0, -1, -2, -3, -4, all the way out to infinity. 0, 1, 2, 3, 4, going on and on forever, all those whole numbers. We've already talked about what a rational number is. That would be an integer, fraction, or a terminating or repeating decimal. That was a typo on my end. So integer, fraction, terminating, or repeating decimal. So let's review how we set up our number line for integers. So when we look at our integers in the number line, we have our 0 in the middle, and our positives are going to move to the right, and our numbers are going to get bigger. Our negatives are going to move to the left, and our numbers get smaller. The further left you go, the more negative you get. Further right you go, the bigger your number gets. And so it's kind of a mirror image on each side. We have 0, 1, 2, 3, 4, and then it goes backwards. -1, -2, -3, -4. We've already talked about how you set up your number line for fractions. So we're going to have our 0, and then you would count by whatever your denominator is. So 1/4, 2/4, 3/4, 1 whole. Going the other way, it's the exact same thing. -1/4, -2/4, -3/4, and -1. Decimals we're going to be breaking up into tenths. And so I counted to 5 tenths, and then if I count 5 more, that takes me to 1 whole. If I count backwards, I have a -1 tenth, -2 tenths, -3 tenths, and so on and so forth to -5 tenths and a -1. So if you just remember you break it up into tenths, that will help you to graph it. As I move down, the directions say graph the following rational number and its opposite on the number line. So in order to know how to graph its opposite, when we talk about opposites in math, positives and negatives are opposites. So if I wanted to graph 3, I'd put 0 in the middle of my number line, and I would graph 3 and -3. If you need to pause at any time during this video to do the problem along with me, go ahead. I'm going to go ahead and move through, and you just pause the video as needed. If I want to graph a -5, the opposite of -5 is a +5. -5 and 5 are opposites of each other. If I want to graph a -1/3, I break my number line up into equal thirds. So I have a 0, I've got my 1/3, and my -1/3. So there's -1/3, -2/3, and -1, and 1/3, 2/3, and 1 whole. Moving down to the next one, I have 1 and 1/4. So I have to count by fourths. Since I have to graph both the positive and the negative, I'm going to count 1/4, 2/4, 3/4, 4/4. There's 1 whole, so 1 and 1/4 is right after that. And then when I count to -1 and 1/4, I have to break it up to -1, and then the next one is -1 and 1/4. Make sure that you're counting in equal increments by the denominator. So when I want to graph my 4 tenths, I've got 0 in the middle, 4 tenths positive to the right. My -4 tenths would be 4 spaces to the left. If I wanted to graph a -7 tenths, the opposite of that is going to be a +7 tenths. So I graph that at 7 to the right. -7 tenths, I would count 7 spaces to the left. Now, why would these be considered opposites? So why in math is a +2 and a -2 considered opposites? Well, that's because they're the same distance from 0 in opposite directions. So if I look at -7 tenths and 7 tenths, they are the exact same distance from 0. They're just in opposite directions. So they are both 7 tenths away from 0. So why would these be called additive inverses then? So an opposite considered an additive inverse. And that's because they add up to be 0. So when I add negative 3 and positive 3, that equals 0. If I have 3 and then I add a negative 3, that's 0. If the temperature is at 50 degrees and it drops 50 degrees, you're at 0. So when you think additive inverse, you think opposite. So when I go through and I state the additive inverses for these numbers, negative 15, the additive inverse would be 15. Negative 17, additive inverse is 17. It's the opposite. 8, additive inverse is negative 8. 0, it's just 0. So additive inverse, think opposite. It's the opposite number for additive inverse. When I add additive inverses together, the sum is going to equal 0. Now this says for each situation, give an integer to represent the situation and state its additive inverse. So if I wanted to show a withdrawal of $50, so withdrawal is when you take money out of the bank. And our integer is going to show what's going to happen to that bank account. So withdrawal of $50 is going to be a negative 50. What would be the additive inverse to that? What's going to undo that negative 50 or be the opposite of a withdrawal? Would be a deposit. You put money into the bank account. So that would be a deposit of $50. A price increase of $8.50. So to represent that, it would be $8.50. It's positive. The additive inverse to that would be a decrease of $8.50. It would take it back to where it started. 80 feet above sea level, 80, and 80 feet below sea level would be the additive inverse to that. A loss of 10 yards would be shown as an integer as negative 10. The opposite of a loss of 10 yards, if you want to get back to where you were, you would have to gain 10 yards. That takes you back to 0. So what are some real-life examples of additive inverses? Well, if you're like me and you like sweets, one example might be I bake 12 cookies, then I eat 12 cookies. So I'm back to 0 cookies. I have nothing left. Football is always a really good example of additive inverse. Like our last one, a loss of 10 yards and a gain of 10 yards. Those are additive inverses. So our next learning target we're going to look at is I can evaluate an expression that includes absolute value. So what is absolute value? Well, absolute value is a number's distance from 0. On a number line, we're going to graph negative 5 and show its absolute value. So if I graph negative 5, how far away is negative 5 from 0? It's 5. Your distance, because this is a distance, it is always positive. So distance, or absolute value, is always, always positive. Different than additive inverse. Additive inverse, you think opposite. Absolute value, you think distance, so it's positive. So number 1, the absolute value, that's the absolute value signs are 2 bars straight up and down. The absolute value of negative 5 is 5. Absolute value of 15 is 15. The absolute value of negative 12 is 12. Notice how all of these are positive numbers. Number 4, the absolute value of negative 8 plus the absolute value of 2 would just be 8 plus 2, so you get 10. Number 5, absolute value of negative 10 is 10, minus the absolute value of negative 6 would be 6, so 10 minus 6 is 4. Absolute value of negative 8 plus the absolute value of negative 3, so it's going to be 8 plus 3 is 11. 2 times the absolute value of negative 3. If you don't have an operation sign there, it's right next to it, that means multiply. So that's 2 times 3 would be 6. 5 times the absolute value of negative 10 would be 5 times 10, so that's 50. So what is going to be our difference between additive inverse and absolute value? So additive inverse think opposite. So additive inverse, 5 and negative 5 are additive inverses. Absolute value is a distance, so it is always positive. So the absolute value of negative 3 is 3. What is going to be the absolute value of 3? Still going to be 3. They are both 3 away from 0. So the absolute value of negative 3 and the absolute value of 3 are both going to be 3 because they are both 3 away from 0. So hopefully you've got a good understanding of the difference between additive inverse and absolute value, and we'll be using that as we move forward to talk about adding integers in our next lesson. Have a great day.